Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming all my grade 10 elite math students to Term 1, Lesson 4.2 Inverse Functions and Relations. Today's video is part 1 of the series and we are going to do this lesson in two parts. In today's session, you will be learning how you can find the inverse of different relations. So let's dive into the video, and before we do that, a humble reminder, a kind request for all my dear viewers and students which are watching my video, liking my content, to please subscribe to the channel so that it gives me the motivation to make more and more videos for all of you. So first we need to understand the key concept of inverse relations. Recall that a relation is a set of ordered pairs. So if you have an ordered pair x, y, then its inverse you can get by exchanging the x and y coordinates. So y comes here, x comes here. So inverse relation is the set of ordered pairs obtained by exchanging the coordinates of each ordered pair. So this is what is called inverse relation, and the domain of the relation becomes the range of the inverse, and the range of the relation becomes the domain of the inverse. So there is an exchange which happens. Okay, so two relations are inverse if and only if whenever one relation contains the element AB, the other relation contains the element BA. So if your A set is denoted by 1, 5, 2, 6, 3, 7, as an example, then B would be its inverse if you exchange the x and y coordinates. So 1, 5 becomes 5, 1, 2, 6 becomes 6, 2, 3, 7 becomes 7, 3. So this is how the exchange is happening. And how do we write the inverse? If the given function is fx, that f inverse is written in this way. So you write f with a -1 and then x. This is the way to write inverse of fx. This is the notation. Okay, and let's take an example, then we'll do a question. This is an important question. We are going to do this question on Desmos. We are going to use the graphing calculator for doing the graph and then checking your answer. So the vertices of triangle ABC are represented by this relation. So there are 3 points given to you. You can name this A, B and C and then join them to get the triangle ABC. So this blue triangle here in the coordinate plane shows you the relation which is given in the question. We need to find its inverse. So first you graph ABC triangle, and to find the inverse you exchange the coordinates. So the new inverse relation becomes -2, 1, 5, 2, -1, 4. Now you can plot these points also as ordered pairs to describe the vertices of the inverse. So triangle A prime, B prime, C prime is the inverse triangle or the inverse relation of triangle ABC. So the green one, A prime, B prime, C prime, if you join this, becomes the new triangle which is denoting the inverse of the given relation. Now if you observe what is the relationship between the blue and the green, then the green triangle A prime, B prime, C prime is a reflection of old triangle ABC over this line. So if you look at this line y equal to x, the red dotted line, then there is a reflection happening. The point which is here reflects here, the point which is here reflects here, the point which is here reflects here about this line. So this is an important property. So whenever you are graphing the inverse, you can directly find the reflection along this line and get your inverse. So that's what we are going to do here. So let's go to Desmos, do this question. So we are going to take A, B, C as these 3 points. Then we will make A prime, B prime, C prime, means the points will be -3, 8, -6, -8, and -6, -3. So these 3 different points we are going to draw, and then we find the inverse, which we'll see how in the graph it looks like. So it will be a reflection definitely along the line y equal to x. And let's now go to Desmos and do the graph. Okay, so let's start now graphing of the relation and the new one, the inverse function. So how we are going to do, we are going to mark the points. So the first point which corresponds to point A is this. We are going to label it as capital A. Okay, so that's your point number one. Next point that we are going to plot, you can see how Desmos is drawing the point. Next point is -8, comma -6. We are going to label it as point number B. You can see how the green dot is now made. Next and the last point would be C, which is -3, comma -6. And we are going to label it as C. Okay, so now we have got all 3 points. We are going to join them. Let's do that. So this is A, this is B, this is C, as you can see. And now we are going to do the next one, which is A prime, B prime, C prime. So -3, just interchange. -3, comma -8. That's your A prime. Let's label it as PQR. Then next one is -6, comma -8. You can see how the points are coming up in the graph. That's point Q. And last point is the inverse of -3, comma -6. So it will be -6, comma -3. That's the point R. Okay, so we have got all the points. Now we are going to also draw one more thing, which is the line y equal to x, because I really want you to see how the inverse is happening, how the graph is going, having the inverse. So see, A, B, C is here. So what is the reflection of point A through this line? R. Then what is the reflection of point B through the line? C. What is the reflection of the point C through this? The next point. So A reflection is P, B reflection is Q, R reflection is C along this line. So that's why if you really want to join, I'm trying to join, but I don't see an option here. Just give me 1 minute. Let me see. Okay, no, I'm not getting an option. But any which ways, we'll go to, we'll take a picture here. We'll stop the recording now and we'll go to our presentation back again, and there we'll join them. So let's complete the triangles now. So A, B, C, first we are going to join. Let me take red color. So A, B, and C. So this is the first triangle. As you can see, it's a right angle triangle. Then with black, I'm going to denote PQR. So P, Q, and R. Again, it's going to be 100% a right angle triangle because they are going to be symmetric about this line. So you can see this is your y equal to x, the line, and both the triangles are symmetric. So now we can just do one more thing. We'll do the marking. So for A, the reflection is this. For B, the reflection is this, and for C, the reflection is this. So therefore you see they both are symmetric. That's how the graph is going to look like. Some properties of inverses. So the property says that if f and f inverse are the inverses, then if f of A is B, if and only if this happens, if f inverse of B is A. So how it is coming, let's see. If this condition is there, we can take f inverse on both sides. So what happens when I take f inverse? Here it becomes f inverse B on the right side, and f inverse of f of A would become A itself. So that's how this relation is coming, because f inverse with f is identity. Okay, so f inverse of b equal to a, this has to be true. So let f of x be this function and f inverse is this function. Then if you find it, the value of the function at any point, for example, I take x equal to 6 and I find f of 6, then this value is 2. So its inverse will also have at the same point the same value. Means if I find f inverse and I plug in value 2, then it will give you the same value 6 that you started with. So that's the property, that f of a equal to b if and only if f inverse of b is a. So because they are inverses, this property is going to hold true. The given function, the given relation, and its inverse. You should also know how to find the inverse. So there are going to be 4 steps that we use, and finally the graph that we do to check for the inverse. So I will in detail explain you the 4 steps, and then we'll do one question together. So in step 1, the function is given to you 2x minus 5. First you do is to replace f of x with y. So rewrite the function as an equation relating x and y. So what did you do? You replace f of x with y. So where there was f of x, you put y. So this is the equation that you get. Step 2, you exchange x and y. Where there is y, put x. Where there is x, put y. Exchange them both. And then you solve the equation for y. Convert it and find the value of y. So y comes out to be this expression. And then finally you replace your y with f inverse x. Okay. So when you replace y with f inverse x, what you get is your final answer. You get your inverse. So f inverse is the inverse of the given function. And now comes the graph. So for the graph, you first do f of x. So this is this line. As you know, it will be symmetric about y equal to x, the red dotted line. So the next line will also come out to be symmetric. And again, you can check this on Desmos. We'll do one question now, and you will see how the graph of the inverse will be the reflection of the initial graph along the line. So let's go and solve a question together. Okay, so let's solve this question together. There are 2 parts to the question. First is where you do step 1, 2, 3, 4 and find the inverse. And step 2 is where you do the graph. So for graph, we will go to Desmos and see our solution there. Let's do these 4 algebra steps. So rewrite the function. So the function is given f of x equal to 3x plus 2. So I rewrite and replace f of x with y. That's step 1. Okay, so step 1 is done. Step 2, exchange y and x. So where there is y, I put x. Where there is x, I put y. So I've done the exchange. Step 3, so this is 2. Now step 3 is you solve for y. So can I write this 2 here? So x minus 2 is 3y. Now divide by 3 on both sides. So what do you get? This coefficient cancels and y is this value. So you have got in step 3 this one. Now you replace y with f inverse of x. So your inverse you have already got. So this is the inverse of the given question. So what was given? Inverse of f of x function, which was 3x plus 2. So now you've got both of them. So we are going to do graph of this inverse and the given function, and we'll take the reflection along the line y equal to x. So let's go to Desmos. Okay, so let's draw the graph of f of x now, the function which is given in the question. So f of x is given as 3x plus 2. So this is the straight line. You can see the graph. Now we are going to draw the graph of f inverse of x. So f inverse of x is the division. So we are going to go here and do the division. So first I'm going to write x minus 2 in the numerator and then divide. Uh, okay, let me go back and just change a few things here. So I'm going to put brackets so that we have the correct division now. So now it is divided by 3. So this is the function. Okay. So I'm going to now zoom out a little bit to show you both the functions on the same graph. or let me just name this as gx for a better understanding. So now it is better. So g of x is this function. Now we are also going to draw y equal to x, just to make you understand how the three graphs are symmetric. Just see, the green line is y equal to x, the red line is the function original, and blue is the one which is the inverse. So you can see very well how the symmetry is happening. I will zoom out a little bit more to make it easy for you. So this is how the inverse graphs are plotted. Time to test you. So do this question yourself. F of x is given to you. Find f inverse x and then use the Desmos graphing calculator to draw the inverse. So try this question yourself, and just to help you out, your textbook questions from the guided practice I have solved here, and the solution is provided. Do check your answer. You can solve them step by step like we've done in today's session, and put them in your notebooks. And also the unsolved questions of your math book, I have put here the answer key, so you can always check your answers, check the graphs also, and solve them in your notebook. So that's all for the session today. That brings us to the end. Thank you for joining. And coming up next would be part 2 of this lesson 4.2. So do subscribe to the channel if you haven't done that till now. Press the bell icon so that you don't miss the upcoming videos. And if you found this video useful, do like it, give it a thumbs up, and share with your friends who will benefit from it. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye, students.